There's this one number that haunts the world of physics. It's a number so fundamental and yet so completely baffling that it kind of sits right at the edge of what we understand about reality. That number is 137, and today we're going to dive into why it is just so mysterious.
The legendary physicist Richard Feynman said it's one of the greatest damn mysteries of physics. This isn't just some random number that pops up. It's more like a clue, a cosmic riddle that has obsessed some of the absolute brightest minds for more than 100 years. So here it is, 137. It shows up so consistently, so perfectly placed in the math that describes our universe, that Feynman even called it a magic number. So what in the world does it actually represent?
Okay, so to really get why it feels so magical, we've got to look a little closer. This isn't just some integer pulled out of a hat. It actually represents one of the most fundamental constants of nature.
See, the number 137 is really kind of a nickname. What physicists are truly obsessed with is its inverse, a constant they call the fine structure constant, or alpha. But for simplicity's sake, they often just call it by the number it's incredibly close to, 137.
And calling this thing the universe's control knob? Trust me, that is no exaggeration. This one single number basically dictates the strength of one of the four fundamental forces of nature. So in technical terms, alpha measures the strength of electromagnetism. It's what's known as a coupling constant. It determines how charged particles, like electrons and photons, interact with each other. A good way to think of it is like the master volume dial for pretty much everything electric and magnetic in the entire universe.
And the consequences of that are, well, they're profound. Alpha dictates how tightly an electron is held to an atom. It governs how stars shine and how sunlight interacts with everything it touches. It is the reason the periodic table is structured the way it is, which, in turn, allows for the complex chemistry that makes you and me possible. It's not just some footnote in physics, it's the foundation of reality as we know it.
And this is where the precision really matters. Experimentally, scientists have measured its value with incredible accuracy. And while we often just round it to 1 over 137, this long string of numbers is what the universe is actually running on. The question that keeps physicists staring at the ceiling at night is, why this specific number?
And this is where the mystery gets even weirder. Unlike, say, the speed of light or the mass of an electron, alpha has no units. It's not meters per second, it's not kilograms, it's just a pure raw number. Its value is exactly the same no matter what system of measurement you use, whether you're right here on Earth or in a galaxy billions of light years away. It is truly fundamentally universal. And believe me, this isn't some new puzzle we just stumbled upon. The fascination with 137 has been going on for over a century, and it has captivated some of the most legendary figures in all of science.
It all started back in the early 1900s with observations of how atoms give off light. Soon after, the physicist Arthur Eddington became absolutely convinced its inverse had to be exactly the whole number 137. When experiments proved him wrong, well, he just adjusted his theory to make it fit. For Wolfgang Pauli, the obsession was so intense that he famously joked that the first thing he'd do in hell was ask the devil for the meaning of the fine structure constant. And then, of course, Feynman cemented its legendary status in 1985.
And its influence is just everywhere, from the bizarre quantum dance of particles in QED, to the large-scale structure of the entire cosmos, and even in the wild, esoteric physics of black holes, this one number just keeps showing up. It's like a signature written across the very fabric of the universe.
And its universal presence brings us to the most profound part of this whole mystery, the sheer, unbelievable luck that it has the value that it does. It's a coincidence so perfect it feels almost suspicious.
So why this number? We have no theory, none that can predict its value from scratch. We can measure it with incredible precision, but we can't for the life of us explain it. It really seems to have been dialed in with impossible precision, and our very existence depends on it. Just think about this. If you were to change the value of alpha by only 4%, let's say making it 1 over 132 instead of 137, the universe as we know it would just break. The electromagnetic force would be too strong. Atoms would collapse on themselves. If you tweak it the other way, stellar fusion, the engine that powers stars and creates elements like carbon, would just stop. In either of those cases, life would be completely impossible. What this means is that our universe isn't just described by this number, it's balanced on it like a pin on a knife's edge. This is the heart of what's called the fine-tuning problem. Our very existence seems to be a direct consequence of this very specific, completely unexplained value.
So how do scientists even begin to explain this cosmic coincidence?
Right now, there are basically three main schools of thought, three possible solutions to the grand mystery of 137.
Okay, the first possibility is maybe the most unsettling one. It's just a brute fact. In this view, the universe is just this way. There's no deeper reason why alpha is 1 over 137. It just is. We just happen to get these settings when the universe was born. End of story.
The second idea is a little more philosophical. It suggests that maybe there are countless other universes out there, a multiverse, and each one has a different value for alpha. Most of them would be totally sterile, lifeless places. And we, of course, just happen to find ourselves in one of the few universes where the conditions were just right for life to show up and start asking questions about it. And that's the core idea of the anthropic principle. It's basically a form of observation bias. It's not that 137 is necessarily special, it's that any universe that could be observed has to have a value for alpha that's compatible with having observers in the first place. But the third theory, this is the one that really gets physicists excited. This is the hope that 137 isn't random at all. They believe it's a direct consequence of a deeper, more fundamental theory, maybe a theory of everything, that we just haven't discovered yet. In that kind of theory, the value of alpha wouldn't be a coincidence. It would be an inevitable mathematical outcome.
And that really brings us full circle, back to Feynman. His awe just captures the feeling perfectly. This number feels almost designed, like it's a message we just haven't figured out how to read yet. We know how to measure the final answer, but we have no clue how the calculation was done.
And so, we're left with this enormous question. The number 137 isn't just a number. It's really a symbol of the boundary between everything we know and everything we don't. And you have to wonder, if we ever solve its mystery, will we not just be explaining a constant, but finally unlocking the fundamental logic of the cosmos itself?